Welcome back to a developer's guide for Windows 10 Insider Preview. I'm Jerry, this is Andy, and we're here to talk to you about app-to-app communication. That means your application can speak to another application that's installed on the same device. It's pretty cool stuff.
Yeah, there's lots of facets to this. So, your app is running on a target device, but there's lots of kind of situations where you might want to launch out to some of the built-in stuff, some of the built-in apps, or to other apps that you've created, or think of an enterprise LOB. But there's also a lot of new stuff coming out as well. We've got another session on app services, which is worthy a topic of its own, but it's another facet of this. But there's cool stuff about how your app can communicate with other apps, get a web of apps going, and allow one app to provide services to another app. So this is not a new feature. We had it in 8.1, so we're going to first of all just review what we had there, and also kind of what were perceived to be some of the improvements that could be made to that, which is what we've got in UWP. So we're going to go through that, a couple of demos, and a brief mention of some of the other ways of sharing stuff as well.
I was thinking about UWP and how to pronounce it, like UWP or UWinP. I thought about that.
Okay.
Just see how I can make it flow.
Yeah, UWP works.
All right, app-to-app in Windows 8.1, that's where we'll begin.
It's been a long day.
Now, this is the way app-to-app worked in Windows 8.1. It started with, basically, the ability to call your application based on a custom protocol that you set up inside your application. So a protocol is a simple thing. We are used to, for example, HTTP:/, and what that really causes is the browser to be invoked. Just like we're used to mail-to: as another protocol, that causes your email client to be invoked. Well, you could also create sample app: or something else that's specific just for your application and register it when your Windows application is installed. And whenever that is, calling that protocol means that it's calling your application. And very powerful. You can even pass variables to it, just like you would in a regular URI.
Yeah.
That's powerful. But there was a limitation to it in that I would call Andy's app : and that was really, really nice. But I never knew if Chris had created his own Andy's app : application and when I called out to, how could I be sure that I was calling yours or if I was calling Chris's?
But this was, let's be clear, this was by design, really. I mean, on the graphic we had before, the key thing is that the middle bit, it says the user/OS chooses target.
Right.
So it was meant to be decoupled. So the client app on the left there just makes a call, launch URI async, and it's throwing out a URI with some data in it. And then the idea is that the user then has installed their favorite sample app processing app, and they can then choose to invoke that app in the chooser dialog that comes up.
So the other way we could do it, if we didn't use a protocol, we could use a file. And so I could register my application so that it has a file extension, sort of like how the Adobe Reader opens up a PDF. They have registered for the PDF extension. You could also register then for the invoice extension, as an example, and your billing system would launch and it would load up that file. So I could do it with a custom protocol, calling your application, or I could invoke your application with a custom or just a registered file extension. So a couple of different ways in Windows 8 that we could invoke an application.
Yeah, and the way that your app registers to say, I know how to handle sample app URIs, it's just some stuff in the manifest.
Quite simple.
Quite simple.
We did it in a WPF as well, but it was a load of work to get it to work. Here it's just like, and you're done with it. It's really nice.
Another way that apps in 8.1 could share stuff is another thing called the share contract. So this is a way of an app having content to share, and it's very rich. Basically, the sending app, the sharing app, creates a data package of stuff that it's able to share, and that could be files, it could be text, it could be images, whatever it has to share, whatever is appropriate, and we've got another module on this, actually, which we'll run another time. But then, again, the shell comes in and puts up a picker UI that the user then says who I want to share it with. So that might be Twitter or Facebook or your app or whatever. So the user, again, chooses where that's going to go. And the share contract just is a decoupled way of connecting a sharer with a sharee.
Just like everything else, I don't know if it's sharee or not.
No, I was struggling there. I was thinking, what is that word?
A little port or sherry. So as it turns out, the share contract will solves a problem of two applications, because two applications that can't talk to one another. That's just one of the rules of Windows apps, that one app can't talk to another. And the reason for that is you don't want to make another app unstable. So the operating system works as a broker between them, and you pass a payload to that broker, which then passes a payload to the other. So you're sharing data, but you're really sharing through the share broker. Yeah, it's pretty powerful,
That was all good.
it was pretty good. Yeah, you could do a lot of interesting things.
But there are a number of things that people have asked for. So if we'll now take a look at app-to-app in Windows 10 and look at some of the great new enhancements that have addressed some of those big asks from people who have been trying to use this kind of technology. So there's 4 areas we can kind of look at. First of all, this is the one where you're using Launch URI, but you don't want the user to be able to select who it is. You actually want to use this as a strongly coupled way of launching another app.
More importantly, perhaps, is that like our earlier sample where I'm calling Andy's app, and Chris, I know, also has Andy's app, and I realize my users are getting confused. They don't know which one to go to, and every once in a while they'll go to Chris's version, and they don't get the experience that I want them to have. How do I specify just you? I do that by right here by launching a specific app.
That's right. And sort of enterprise LOB customers as well. If you're creating this a suite of apps, cooperating apps that are driving some of your business needs, again, you need to know that you can use this as a mechanism for transferring control from one app to another, but you want it to be a specific app that you're launching. So we can do that now. Yeah. There's also, before we had launch file, I mean, that API is still there.
Pass a string.
Yeah, that's right. But now you can actually launch, that kind of worked up to a point, but didn't work so good with big files. So now there's a new way of sending a file token, which is kind of an access token, and sending that over. So there's a new way of sharing files.
A cleaner way that allows me to use a type of dictionary to be able to pass values across to have a key. So I'm not trying to parse a string and that maybe I get right, maybe I don't get right. But I also have the ability to share not just strings of data as I'm passing along, but also this ACL, or this token that represents access to a file.
That's right. There's also launch for results. So this is the problem, if you like, or this solves the problem very nicely, that with the launch URI in Windows 8.1, it was only one way.
That's right.
So one app could launch another, and like we also had this problem that you couldn't actually direct it to definitely another one.
Right.
But then what happened if that other app did some processing and it had some context and data it wanted to pass back again?
Yeah, it's some version of like PayPal or something, and you send off to that and to do all the money processing. Well, you don't want somebody to spoof it and pretend like you just paid for it and get all of your products shipped to you when you didn't actually pay for it.
No. So we kind of in 8.1 you had to do this back-to-back activation. So the one app would launch another one, and then when the other one wanted to pass something back, it would launch the original one back in return. But there were all the problems that we've already identified about making sure that the right thing happened at the right time. So we've now got a strongly typed API, launch for results, which just allows that kind of behavior. And the last one is app services, which is a kind of, think of this like having background tasks that can be invoked by anyone, anywhere. So that is
almost like calling a web service.
Exactly like calling a web service. So think of it as like on-device web services. So that's that's a big enough topic that we're going to cover in a whole module of its own.
Good, because they are awesome.
They are awesome, yeah. So how do we invoke a specific app?
Yeah, what does it look like?
Really simple. So if you remember, the 8.1 syntax was launcher.launch URI async and then just the URI. So it's now, there's an override of that where you can specify on the launch URI async a launcher options object. And in that, there's a property called target application package family name.
Yes.
So what is a package family name?
Well, that's that unique thing that the store gives to an app. So as soon as I register my application with the Windows Store, I get a package family name, and it's really just a unique name. Sometimes it's a part of a GUID is included there. It's a little bit of the string of my app's name, but what I can be sure of is it's unique across the entire Windows Store.
That's right.
So calling that application means you're not calling another one.
That's right. So it uniquely identifies that app. And so you get that through registering your app with the store, which we can't quite do yet. But it works with debug as well for now. So I mentioned also there's this way of sending file tokens. This is how you can send file tokens across. It's basically the same, launch URI and an options, again, if you want to send it to a particular app. But then there's a third parameter to launch URI async, where you can pass a value set, which is this this dictionary of
That's all
time.
that it is.
It's just a dictionary, which you can send across over to the target as well.
So value set, I'll just jump in real quick to say the value set is a fully serializable iDictionary. So it's a little bit different than the dictionary you and I are used to using, only because it's a more of a primitive, so it's easy to pass around.
Yeah. Now, one of the things you can put in that value set, you can put anything in that value set, but one of the things you could put in that is a shared storage access manager file token. So this is you, the sender, saying, all right, I've got this file, it's in my storage area, but here's a token I'm going to send over to this app I'm launching.
That's right.
And that the receiver can use that token to get access to that file, and it can work on it. So you're just sending the token over rather than the whole file. So it's very efficient and a good way of sharing access to the files.
So the important takeaway might be that if you're sharing a 2 gigabyte file, you're not passing a 2 gigabyte file.
Yep.
You're passing that tiny little string that gives it access.
That's right.
Very nice. Okay.
One more new API in this kind of set that is very helpful, which is this allows the sender. So here's the other thing. If you use the kind of 8.1 model, or even actually the new one with the launcher options, so you're launching a specific one, what if that target app isn't installed?
Yeah, what's the user's experience?
Yeah, what is the user experience? So, in actual fact, the user's experience is it will pop up, the shell will pop up something saying, you haven't got an app installed to handle this.
Yeah.
Do you want to go off to the store and find one? So it will send you off to the store and allow the user to download that app. Now, that may be an acceptable way of handling it in a lot of cases. There's nothing wrong with that. But this allows you to handle that in your own way in your app. So you can query up front, has this device got an app already installed to handle this URI?
So in Windows 8, we never had the ability to query to see if another app was installed.
Nope.
This is introducing that ability, so I can say, I'm going to have a dependency on this, this, and this. Are they installed? And if not, interact with the user to warn them that your app is going to have diminished functionality. Obviously, you're going to code with some defensive programming so that if they don't install those, your application doesn't explode.
That's right.
Yeah.
Yeah, so there's two examples on this slide. The first one is just a generic, is there any app installed to handle this URI? And then the second example is this specific app to handle this URI with this package family name installed?
Yeah.
So that's the specific one. So that's kind of nice.
It's super nice. That's exactly right.
Yeah.
Super nice.
Now the last one, like I said, we're not going to talk about this because it's a big enough topic of its own. We're going to talk about this in some depth in another module, which is app services. This is the web services model, but on device. Mm-hmm. So here you've got a background task of an app over on the right,
That's right,
which client apps can invoke and get it to do stuff. It's very nice. The background task is kind of long-lived, and once initialized is just sitting there waiting to handle requests. A real nice way.
What's beautiful about it, there's no UI, so I can invoke your application to go, so you can provide some information to me, and I never have to worry about the user seeing things popping up or whatever. Your background task handles it all invisibly.
That's right. That's right.
A lot of power.
So we'll look at that later on.
Oh, nice.
Yeah, this is nice. What a long list of URIs, huh? Yeah.
It really is. You know, this is really handy to be able to interact with the core system.
Yep. So this is the same mechanism, launch URI async, but this time the destination URI is some of the built-in apps, some of the built-in settings. So pretty useful to get the user directly to, for example, your Bluetooth app, Bluetooth's not switched on. You can actually take them directly to the Bluetooth settings and allow them to turn it on.
So this isn't your application making changes to those settings. This is your application making it easy for the user to jump to those settings.
Exactly. Invokes that settings page, directly. So there you go. Yeah.
I think it might make sense for us to look at how we can activate an app with a URI or with a custom protocol.
Yep. Okay. So all right, let's switch to a demo. Yeah. Okay, so here we go. I've just got a very simple one button. We can go and look at what the code is, and not surprisingly, it's just a 8.1 style launch URI async. So first of all, let's look at the experience. I'm going to use the phone in this case, but this obviously works right the way across UWP. We're going to install this app and hit the button. I haven't got any handlers installed. So this is the phone experience. Do you want to search for an app in the store? And you can say, yeah, let's go off and look in the store. Now, currently, the UI of the store here is not implemented, so we actually get a pretty ugly page up. There you go. That's pretty good, huh? It's
not that ugly.
No. So there will be a proper store page there in time. Okay. But now I've got two other apps in this solution which are handlers. So both of them have got in their manifest, scroll down here, and you can see this is the extension bit that says, I know how to handle the protocol W10 Tech Preview.
Got it.
All right. So that's all it needs. Windows.protocol. And the other one, that's first protocol handler. So I can deploy that to my phone. So I've now got one app on the phone that can handle that W10 Tech Preview.
Now this is important. Deploying it to the phone also registers that protocol.
Exactly. So it just needs to be installed by the user in terms of from the store. If this was a real, fully acquired from the store, but it works just the same in Visual Studio. Just deploy it. Here's the other one, and it supports the same protocol. So we've now got two apps on this device when I've deployed it. There we go. Let's deploy that as well.
Each with the same protocol.
Yeah, and now we can go off and look at the apps list, and there you go. You can see at the top, I can handle that, and yes, but I can do it better. Those are the two protocol handlers, and this is my client app, so let's just launch that again. Hit the button, and this time the shell puts up a choose an app thing. Say, which one do you want to handle this? So you can choose one, and I'm going to choose yes, but I do it better. So now we're in the second protocol. We've now switched control. We're now looking at the UI from the second protocol handler app.
Ah, good.
So that's all right, but what if you didn't want that? You actually really wanted to invoke the I can handle that app.
Yeah, that's right.
So what we need to do, I've actually got in the main page of this, we've actually got in the initialized component there, we're writing the package family name. This is how you find out what the package family name is of this particular app. So we just run it directly, and down in, when it loads, that'll just write to the output window down here. That is the package family name, so I'm just going to copy that.
Now, you could do this even if you've registered with the store, but the store will give it to you as well.
Yeah, the store will give. If you've got an app that you've gone through the store registration process, you'll know what that is. And now here we can change this now. So we can create ourselves a new launcher options.
Okay.
And we can set into that.
So this is a special type just for passing this.
Fix up the namespace. And then we can options dot, it's down there, the preferred application package, target application package family name is equal to, and then we just paste in that value that we copied. So this is the PFN of the
Boy,
other
it looks
app.
unique. Whew.
Yeah, it certainly is. And now we can use this override of launch URI sync and specify that option. So now, when we run this,
yeah, what's going to happen?
We will, it should, and I'm sure it won't be a surprise to you, that when we hit that button, it's going to go to, not the second one that we had before, but it will go directly to the first protocol.
So the user doesn't get a picker popping up.
You don't get that choice anymore.
There's no purpose to pick because it's already procured.
Exactly. Yes. And it's worth mentioning that desktop has slightly different behavior than phone. So you don't have that picker on desktop. PCs and that, you actually have the preferred app is in the system settings. So you choose app in there. So it's not quite so interactive as it is on phone, which is why I chose the phone for the demo.
But it is the same that if it's missing completely, it does prompt you to go to the store.
Yeah.
Yeah, that's right.
Exactly so. Exactly so.
Very nice. All right, so that's launching a specific app.
Yeah.
And but we talked about I can not only launch a specific app, I can ask that app to do something for me and hand me back whatever it is I asked.
So this two-way launch for results transaction. So here we go. The first bit's pretty much the same, except instead of launch URI async, it's now launch URI for results async. So this is we're saying I'm going to launch this other app and then I'm going to sit around and wait for a response to come back. And what you pass over, you can pass over, well, this one is not passing anything. It's just passing the URI, a bit of data in it. But you could pass a value set over to the data. Oh, it's not shown, actually. The data is shown in the snippet in launch URI for results async.
That's right.
So you're sending a value set over to the other end. The other end does its stuff, pops up its own UI, does whatever it has to do. And then when it's ready to return control to the caller, it just calls the protocol for results operation .report completed method on an object that it receives when it gets activated.
And that's basically the value set that it's returning.
Yeah.
I see. And then so that A at the end of the line is a new syntax?
It's a complete typo. Thank you, Gary. Thanks for that. Yes.
By the way, out of curiosity, when I call the second application, does my first app, is it suspended?
The first app is suspended. That's right. Yes. Yeah. Although actually it is on the phone. On the desktop, it's not, because you actually see two windows there. So
that's right.
In fact, I'll run the demo on the desktop, I think, when we get to this, so you can see that.
It is suspended if you're on the phone. It is suspended if you're in mobile.
Yeah.
Even on the tablet,
yes.
but it's
so
not suspended on desktop.
Yeah,
right.
so on a small tablet you'd be running full screen as well, so you get the same phone behavior.
We have a session on Lifecycle that will talk this through, but Lifecycle has changed slightly, and that's kind of out.
That's right. So it's kind of interesting with the desktop story. All right, okay, so let's have a look at this one, Launch for Results. I've got a demo that nicely shows how this works as well.
Okay.
Okay, so another one I'm just going to walk through is I've got two projects in this. First of all, Shop, which has got a green screen, so you can see where you're in the first app. This is the Shop. And then we've got a Checkout app, which is the one we're going to launch, which has got a nice purple screen, so you can see when we're in that.
Very distinctive, very distinctive.
Yeah, it's not going to win any awards, but here we are. Let's just run it, and so you can see how it works. So here we are in the client app, and we can now choose some products. I'm going to choose a sprocket and a contraption.
Oh.
And then we hit Checkout.
These are expensive.
And now we've hit this is the breakpoint in the Checkout button handler, so we're still in the calling app. This is how we're going to invoke the other guy.
Gotcha.
We're building a value set. And then we serialize it with JSON, and we're putting that into our value set.
You don't have to. This is what you've chosen.
This is what I've chosen. Yeah, we're just sending some data to the other set, and then here, when I step through this, now transfer controls is now the other. So this is the window for the other app. This is the Checkout app. You can see it's sitting above the other one. We've now come back, closed the other app, and we're now back into the caller again. And now we can navigate to another page, which is the kind of we've done kind of page.
Your credit card didn't work.
That's because I cancelled it. Yeah. Now I'm going to show you how you debug the actual other side of it. So we stepped through on the client side there, but now what I want to do is debug the
checkout?
The Checkout app. So the way you can do that with these kind of soft launch kind of things is down in the debug, in the properties, this is do not launch, but debug my code when it starts. So if you then run this in the debugger, what happens is it launches a debug session but doesn't launch the app. So it waits for whatever trigger it is. So now the deploy succeeded. We're sitting there waiting, and I now need to launch the original app. So actually I'm going to ask Cortana to do that because my start button is broken, frankly. So there's the Shop app. There we go. And here we are. The client app's not running under the debugger, so I'm going to buy a widget and a gizmo.
Of course you are.
Check it out.
Yeah, those gizmos are a lot of money.
They are, yeah. And now we're in the onActivated in app.xaml.cs in the Checkout app. Here we go. That's where we are. So just to prove the point, here we are. This is the namespace Checkout. We're in the Checkout app in the onActivated event handler. We do some standard stuff. And then we get this protocol results activated event args, and we're just going to send that object over to the other page, make payment.xaml.cs. We're in the onNavigated too, so we can extract from that. This is the data that the original app sent to us. And here we are. We can actually validate the caller. One way of doing it, you can have a whitelist. We've got this is the PFN, the package family name of the demo
that
show,
is
the
awesome.
caller.
So the app can say anybody can call me or only these.
Yeah, that's right. So and there's other ways of doing that. And then we can actually figure out, pull the stuff out, extract the details of the transaction, and then we can show our UI. So here we are. This is now, we're in the Checkout app. I can choose my payment card. I can make the payment. Now we're in that make payment click. That's the button event handler. Now we're building a value set to send back to the caller. We do a bit of dummy validation. This is all like pretend stuff. And then we report completed. So this is the point at which the launched app it closes, and we're back with the caller. So we've seen both ways, and this time the payment has been successful.
And obviously, you might have like some sort of CRC that you pass back and forth to make sure the values are what you expect them to be.
Absolutely, yeah. You could build all kinds of sophisticated stuff around this. You could even do certificate authentication if you really wanted to do all that kind of stuff.
I could see a line of business application that interacts with some sort of workflow system, but you only want to interact with that workflow system on a single app.
Yep.
So you have that as your controller, and all these other apps leverage it by calling it this way. Really neat. This is some neat business.
It's nice. It's fun stuff. Yeah. We're going to wrap up here with another thing that's related to app to app. And if you've been watching all of these modules, you've already heard about this, but it kind of also deserves mention in this context, which is the publisher shared file thing. So,
well, this is how apps can communicate one way.
Yeah. So this is where, rather than having value sets being passed across before, or having to launch the URI or using app services, this is just a shared file share. So this is where you can have a bunch of cooperating apps, and they've got some kind of common storage. You can just have a common folder where they can read and write files.
This is something new and definitely awesome.
Yeah, this is great. The way that you provision this is you simply add this into the extension section of your manifest, and you have to specify one or more folder, because you can't just read and write files into the root. There is no root, so you have to actually declare folders within that your apps are going to use, and you don't actually have to create them. Once declaring them is enough. So as soon as your app is provisioned, as soon as you, I'm not sure which point, but as soon as you try and use this, if it's declared in the manifest, the system will just provision that folder for you in this kind of shared folder area.
So let's take a quick look at what the syntax looks like. It feels like the API that I'm already used to for interacting with a storage folder and interacting with storage files. All I have to say is get publisher cache folder, it returns that storage folder, and then I just start using the APIs I already know.
It gives you back a completely standard storage folder object. You can use that to all the file-based APIs that hang off that. It's just the same as if it was in your local storage. So it's a real cool way of sharing that. You can clear it explicitly with a API called to clear publisher cache folder async.
Now that clears every folder.
Yeah, that just wipes it out. So that's a pretty blunt stick approach.
Format C:.
It is, yeah. It is. If you don't want to do that, you can simply just leave it to the system, because if the user uninstalls the last app from any particular publisher, if there's any publisher cache folder that's there as well, that would just get blown away at the same time.
So this is shared between apps, but it's not roamed across devices.
It's not, that's right. So it's local to a device.
So we looked at app-to-app communication inside Windows 8, right, and the things that we could already do, and that was already quite powerful. Now we've enhanced that, so now I can call it out to an application, ensuring it's a specific application, maybe for security reasons or for any other reason, really. I can also call out to an application, have it talk back to me, waiting for its result. That's nice and powerful as well.
Really cool, yep. Yes, so there's that, and there's app services, which we're going to cover in another one, querying URI support. There's the shared storage for publisher, which is this kind of shared folder. Yeah. So lots of cool stuff.
Lots of really neat stuff to solve a lot of problems in different ways. Your application may or may not use that exact, all these different features, but hopefully it'll solve the problems that you have. We're going to take a quick break. Andy, come back, talk about more Windows 10.
Yep, we'll see you soon.